Hello, this is a learning video on how to use dimensional analysis to convert from moles to particles or from particles to moles. We're going to use this portion of a mole map where particles are related to moles through this relationship right here, which is Avogadro's number. Avogadro's number is 6.02 times 10 to the 23rd things is equal to 1 mole. Similar to a dozen equals 12 things, a mole equals 6.02 times 10 to the 23rd things. And those things can be atoms, molecules, or formula units. Here's an example of how you would mathematically set up a problem to solve a conversion between particles and moles. So in this problem, it says that you are asked to calculate the number of particles in 4.5 moles of copper. Recall that 1 mole of a substance is equal to 6.02 times 10 to the 23rd things. In this case, since we're working with copper, and copper is an element, its fundamental particle is an atom. So you're going to start with writing out 4.5 moles of copper because that's what you were given in this problem. And then you are going to apply this relationship that 1 mole is equal to 6.02 times 10 to the 23rd things. Notice that I put 1 mole of copper in the denominator, and I put the 6.02 times 10 to the 23rd atoms of copper in the numerator. This is done so that the 1 mole of copper will delete or cancel out the moles of copper. The unit will cancel out from the 4.5 moles of copper that was given. So when you do this mathematical work, then you come up with 2.709 times 10 to the 24th. That's what your calculator states. However, you can only report 2 significant digits because you're looking at the term you started out with, which was 4.5 moles of copper, and there's only 2 significant digits here, or significant figures. Therefore, here you can only report 2 significant figures. And your final answer is 2.7 times 10 to the 24th atoms of copper. Let's look at another example. Here, I'm asking you to calculate the number of formula units in 2.70 moles of calcium chloride. I look at calcium chloride and I notice that this is an ionic compound. I know it's ionic because calcium is a metal, chloride is an nonmetal, or chlorine is a nonmetal. So this is an ionic compound, and the fundamental particle for an ionic compound is a formula unit. So we're going to start with what we were given in the problem, which was 2.70 moles of calcium chloride. So I'm going to write that down. And now I'm going to apply an equivalence, and that equivalence is going to be 1 mole is equal to 6.02 times 10 to the 23rd. Something has to go in the numerator, something has to go in the denominator. In this case, I end up putting the 1 mole of calcium chloride in the denominator, and the Avogadro's number, 6.02 times 10 to the 23rd formula units, in the numerator. When I do this work, I end up getting 1.6254 times 10 to the 24th. Again, that's what my calculator states, but that's not what I can report because I have to go back to the original term, and notice that I see that there's 3 significant figures. Therefore, I can only report 3 significant figures in my answer. So the answer becomes 1.63 times 10 to the 24th formula units of calcium chloride. The third problem that we're going to go over is how would you calculate from molecules to moles. In this problem, I am given 1.4 times 10 to the 23rd molecules of water. Now I'm calling that a molecule of water because notice water is a covalently bonded compound. It consists of two nonmetals. That means it's covalently bonded, and the fundamental unit for that compound is called a molecule since it's covalently bonded. So I'm going to start with what I've been given in the problem, which is 1.4 times 10 to the 23rd. And that's what I write down. I am now going to apply an equivalence, and that equivalence is 1 mole is equal to 6.02 times 10 to the 23rd things. Something has to go on the bottom, something has to go on the top. And notice here I put the molecules of water, 6.02 times 10 to the 23rd molecules of water in the bottom, because I need this molecule term to cancel this molecule term that is in my numerator right here. I need to put it in the denominator here so that they can cancel out. So when I do that, so this molecule is going to be canceled by that molecule. Now when I continue, I end up getting a number of 0.232558 in the calculator, but that's not what I can report. Since I started with just two significant figures here, I have to report only two significant figures, and my final answer is 0.23 moles of water. Now it's your turn. It's time for you to practice and you to try. So what I have here are three problems that I would like for you to try using this dimensional analysis, which I have modeled for you in the previous slides. I'd like for you to pause this slide on a scratch piece of paper. I would like for you to work out these problems, these three problems, and then once you have them done, I would like for you to resume the video, and the next slide will show the answers. So good luck. Okay, welcome back. Hopefully you've done that work and you've shown your work as clearly as here. Here are the answers for those three practice problems that I had you do in the previous slide. Notice that I'm very careful to make sure that what I have here in the beginning of what I've been given, I make sure that it's in the denominator, because that's going to allow for formula units to cancel out and convert to moles of substance, which is what they had asked in that problem. So there you go. This was a learning video on how to convert from moles to particles. And again, particles can mean atoms, molecules, or formula units. Those are the typical particles we work with when we're doing converting in a chemistry class. And what you should know is that 1 mole is equal to 6.02 times 10 to the 23rd things. This is the equivalence, and you get to decide what goes in the denominator based on your problem. I hope this video helps, and thanks for listening.